All right. Good morning, good afternoon, good evening, good night for you night owls out there. Happy Tuesday. Hopefully, you guys are still alive from yesterday. Hopefully, you made some good choices. The only announcement I have is for Thursday meal distributions from 10 a.m. to 1 p.m. Make sure everyone knows, make sure those who need it knows. We need to make sure everyone's being fed and everyone's got what they need. Okay. Another thing is, I didn't know this, but I guess there's a county order. You should have a mask in public now. So just make sure you have something. I don't know, use a rubber band and use a sock or something. Something to keep you covered if you're out in the public. All right. So I want to continue from factoring. We finished most of the meat of factoring yesterday, but I want to finish some of the special topics today. All right, so we're doing factoring by GCF and taking the square root. All right, so first off, GCF. Now, the thing about these topics is that it's not going to tell you factor by GCF. It's not going to tell you take the square root. All it's going to ask you is something along the words of factor. All right, that's all it's going to say. Factor this. What's the solution to this? Right? So we'll have something like 6x squared plus something like 12x. There we go. So we've got this one right here. It's asking us to factor this, right? And what I'm looking for is, well, first off, can I use x method? Can I use x asterisk method? Well, you see, I've got an x squared, I've got an x, but I don't have a constant term by itself. So you could try using the asterisk method, but here's what's going to happen if I do it really quick. So I've got my asterisk all drawn out. B's on top. Well, that's the 12 right here. And then on bottom I have a times c. But I have a right here, so that's 6. And I have c. The last thing is c, but I don't have a c. So I'd have to write 0. And that's where it gets a little funky, right? So 6 times 0 is 0. But then now I'm getting into something weird, where I need something to multiply to be 0, but add it up to be 12. That I'm going to give you, I'm not going to waste your time with this one, because you can't do this one, right? Multiplying to 0 and adding to 12, there's no two numbers that do that. Maybe in a different number system, but you'll get to that in calculus. Don't worry about that one. So, I'm going to keep the problem. We can't use the asterisk method, so we have to use the GCF, the greatest common factor. So I'm going to look at this one, 6x squared, and I'm going to look at this one at the same time. All right? I'm going to see what I can divide both of them by. So I have this 6 right here, and I have this 12. Well, I can divide 6 divided by 6, right? I can definitely do that. But I can also divide 12 by 6. I divided both of them by 6, right? So after I divide, I'm actually going to put the 6 on the outside, make a parentheses. 6 divided by 6, that's going to be 1x squared. And then 12 divided by 6, I'll give you guys a second to figure that one out. Yep, it is 2. And then don't forget that x. Then you're going to close that parentheses. So if I divide both of them by the same thing, I'm actually going to take it out here. It's kind of like telling me, okay, I divided everything in here by 6. So that's what we're doing for factoring by GCF. But I can do one more thing. After I look at the numbers, now I can look at the variables, the letters. So here I've got x squared and x. They both have an x, so I'm going to take out one of the x's from both of them. So divide this by x, divide this by x. Alright, and just because they're letters, just because they're variables, you don't have to panic, you'll be fine. Alright, so I'm going to keep this 6 outside, but now since I took an x out of both of them, I'm also going to include that x on the outside. So I've got 6x on the outside of the parentheses. Then I have two x's here, right? X squared divided by x. That means I'm really doing 2 minus 1. Remember those laws of exponents from a while ago? So in that case, I just have x on the first one. Here, on the second term, I have 1x and I'm dividing by 1x. And you know that if you divide something by itself, you always get 1. So that's what it will look like. Now, of course, I still have this 2 right here. So I'm actually doing 2 times 1, which is just 2. So essentially, to kind of recap that one, I'm looking at both things. What can I divide both of them by? Right? And then after I look at the numbers, I drag it outside. What can I divide? Can I divide both of them by the same letter? Yes, I can. So I'm going to do that. Pull it outside. This is all that's left after dividing everything out. And this would be my final answer if I was factoring by GCF. So let's go over another one. And let's pull it up. Here we go. We've got another factoring one. It doesn't say factor by GCF, remember? So I've got, what is that? 6x cubed minus 4x squared minus 16x. Awesome. Alright, so my first approach, can I use asterisk method, right? And the problem here, this is a cubed, this is a squared, and this is an x. I only want to work with x squared, right? Since I don't have x squared, I can't use asterisk method. So I'll even write that. Can't use asterisk method. So if we can't use the asterisk method, then maybe we'll have to factor by GCF, right? So now I have to look at all 3 terms instead of just the 2 terms here. Well, let's look at the numbers first. If we look at the numbers first, well, this is an even number, 6. This is an even number, 4. This is also an even number, 16. So if they're all even, I can always divide by 2. So that's what I'll divide everything by. Divide everything by 2. So I'm going to, same thing as before, I'm going to pull that 2 outside of the parentheses. And then I'm going to divide everything out. So 6 divided by 2, that should be 3. Don't worry about the variables yet. Just worry about those numbers. Negative 4, don't forget this negative. Don't forget the negative. So negative 4 divided by 2. Yep, it should be negative 2. Don't forget the x squared there. Then I've got negative 16 divided by 2. That should be negative 8x. Oh, there we go. And then you can close that parentheses. And that's your first step. Your first step. All right, so let's look at it again, right? Look inside the parentheses. Can you divide all three of these by the same number? And the answer here is, well, this is an odd number, this is an even number, that's an even number. Well, we can't divide by 2. We can't divide by 3, right? We can't divide by 4, we can't divide by 5. So odds are we can't divide the numbers by the same thing. So that's fine. That is as far as we can go with the numbers. All right, so now we have to look at the letters. I've got an X here, X here, X here. They all have X's, so I can take one X from every single one of them. So I'm going to pull it outside of the parentheses, pulling it out. And so this has 3 X's. I took one of them away. So you got 2 right here. Then I've got that 2, negative 2. I've got 2 X's here. I took one away, so I have 1. And then I have an X here. It's an invisible 1 here. Don't forget that invisible 1. So that means I have no X's left on this guy. I still have the number though. I still get the number. So that negative 8 will still be there. Okay? And then after that, we take one last look at it. And you're looking at the inside of the parentheses. Can I divide all 3 of them by anything? And since we can't, that's our answer. Or is it? Right? So, this is technically the answer, but it's also one step away from the full answer. Okay? So, what do I mean by that? What we can do here is we can actually factor this parentheses right here, right? And how can we do that? Well, I know we said earlier we can't use the asterisk method on this problem, right? But here, since we changed the problem, we can now use it here. So I'll make a small asterisk method, and I'm going to ignore this 2x. This 2x is going to be part of my answer, right? But it's not going to be part of this problem right here. So I'm just kind of ignoring this one, putting it off to the side. I'm just working with this inside. So I'm going to use the asterisk method. So I've got negative 2 up here, because it's in the middle. Then I have 8 times c down here. So that's 3 times a negative 8. And that should be negative 24. And what should go here? What should go here and here? If you answered 3, you'd be correct. Awesome job. So, now we have to play our guessing game. We gotta play that numbers game, right? So, I'm looking for 2 numbers that multiply to be negative 24, but add to be negative 2. So, let's take a look. Multiply to be negative 24, but add to be negative 2. Well, 6 times 4 is 24. Those are 2 good numbers. And then I'm going to make the 6 negative. I'm just choosing, right? I don't know if this works, so I'm going to check it, right? I'm going to take a guess and I'm going to check. Well, Well, negative 6 times 4, that's negative 24. That's good. But negative 6 plus 4, so if I did a plus right here, does that equal negative 2? Yes, it does. So those are my two numbers that I'm going to fill in, negative 6 and 4. Awesome. So this is kind of going back to yesterday, all the stuff that we did yesterday. So I'm going to take a look at my fractions. Can I reduce this? Can I reduce my fractions? Yes, I can. 3 divided by 6. 3 divided by 6. That's actually 1 over 2. But don't forget that negative on the bottom. That's my actual fraction right there. And then I have this 3 over 4. 3 over 4 is irreducible, so we're actually good here. I actually don't need this equal sign here. There we go. So those are my two fractions. So I've got 1 over negative 2 and 3 over 4. And then don't forget this one that we kind of left outside before we started. So now we got to put everything together. All of this stuff together. So I've got the 2x on the outside. Then I've got my two parentheses from yesterday. So I've got 1x. So I'll start that over here. 1x. And then I have negative 2, so I can just write that as a minus 2. Then I've got 3x plus 4. Since this is a positive 4, it can be a plus 4. There we go. And, almost wrote on my, I did write on my wall. That's a rip. That's okay. So, I've got 2x on the outside, 1x minus 2 in the parentheses, and 3x plus 4 is my second factor, my second parentheses. Alright? So, when you get to this question on the assignment, if you circled this for your answer, this one right here, I'll still give you credit, but just know this one right here is the full factorization of this problem. So that one on the assignment, quite a bit of work, but you know, if you really want to get to the right answer, that's what you need to do for that one. All right? So that is GCF done for today. We're going to look at the last kind of special topic. Not the last one specifically, but one of the last big ones for this one. Alright, so this one is called taking the square root of something. I'm going to take some problems off the assignment. Here we go. And this one is asking for the solutions of x plus 7 squared equals 81. And then I'm going to take these off now. Alright. All we actually have to do is take the square root. Okay, so what you're looking for, when you say this, we're looking for the solutions, we're really trying to get x equals something, right? That's our big goal. Whenever you're looking for solutions, you're always looking for x equals something. So we have to do a lot of things in reverse. Okay, so I've got, this is, the whole parentheses is squared, and then I have the 81. Well, here's the thing. If I take, you can try this in your calculators, right? If I take 9 and I square it, that's going to be 81. But if if I take 81 and I do what's called the square root, that becomes 9. Do you see what's happening here? This thing right here, this squared and this square root, they're opposites. Okay? So that's what we're going to be doing in our original problem. So let's take a look. I've got this squared right here. I want to get rid of it. So what am I going to do? I'm going to take the square root of everything. So I'm taking the square root of the left side, but whatever I do to the left side, I need to do to the right side. We're talking about equality here. Eye for an eye, hand for a hand, that kind of stuff. Equality, right? So I took the square root of this side. Well, we just talked about the square and the square root being polar opposites. If they're polar opposites, it means whenever they encounter each other like this, they cancel out. Okay? So this square root, they just disappear. They just straight up disappear, right? Then I've got this, right? If you punch that into your phone calculator, square root of 81, you should get the number 9. Here's the thing. What this really means, square roots, is what times itself gets me this number, right? What times itself gets me this number? Well, 9 times 9 equals 81. That's what we kind of established. But something that we didn't really talk about too much is this case right here. What happens is negative 9 times negative 9, that also equals 81. 81. Well, both of these numbers multiplied by themselves to be 81. So do I put a positive 9 or do I put a negative 9? The answer is both. You put both 9 and negative 9. So I have to do plus or minus 9. This is where it gets a little funky. Okay? What happens is I actually have two answers. I have two answers here that I have to figure out. Okay? So what I need to do is I need to do one case where it is positive 9 and one time where it's negative 9. So I'm going to rewrite this one right here, over here. So I've got x plus 7. I'll get rid of the parentheses because we don't need those. X plus 7. And then this one's going to be the plus 9 on the left side. And then I'm going to rewrite it again, x plus 7. This one's going to be the negative 9. Okay, so all I did was take this and rewrite it. This one's positive, this one's negative. So left side, right side. I'll put a line between the two. All you have to do is solve for x. So here, I've got x plus 7 equals 9. All I have to do is subtract 7 from both sides. Right, so minus 7 here, minus 7 here. Or, I know some of you guys know solving by this way, moving the 7 over to the other side, right? And if it ever crosses the equation line, you have to change the sign. So that works too. Either way works, as long as you're getting to the correct conclusion, right? So, I've got x equals 9 minus 7. That should be 2. That's my left side solution. My left side solution. Now let's look at my right hand. I'm doing the same thing. So this one I'll do this way. So I've got -7 to both sides. -7 here, -7 here. And +7, -7, those cancel out. So this becomes 0, but I can just take out 0. I don't have to write that one. The one I'm worried about is this side. So -9 and a -7. -9, -7. They're the same sign. So it's going to be -16. And what are we looking for? Our goal was x equals something, right? So in this case, x equals 2, x equals -16. So since I got both of my x squareds, I got 2 solutions. I'm done. And that is it for taking the square root as well. So those are my 2 special cases that I wanted to talk about today. That should, let me take a look over the assignment real quick. Yes, we'll go over this one as well. So we'll go over one more to take the square roots. And you should be able to do all of the problems on the assignment now. So I've got this. What are the solutions of 2 times x minus 7 squared equal to 32? So here's how we start this one. Before we took the square root right away. But if you see, the first problem didn't have a number in the front here. That's why we were able to take the square root right away. But since there's a number in front here, it's 2 times this. I have to do the opposite of that. So instead of multiply, I divide both sides by 2. I need to divide both sides by 2 to get rid of that 2. I want to get rid of the 2. That's why I'm doing this. So I got 2 divided by 2. Those go away. That's the magic. That's why we're doing that. And I've got x minus 7 squared on the left side. That is neat. That's what we want. That's kind of our goal to the next step. Then I've got to worry about this side. 32 divided by 2. I'll give you guys a second. Those of you that said 16, awesome job. So this now looks like the first problem. Now it looks like something that we can work with. So I'm going to go ahead and take the square root of both sides. And just like before, this squared and this square root, they're polar opposites. They are inverse operations. Because of that, I can go ahead, those 2 cancel out. So I've got x minus 7. And then this one, I'm looking for the 2 numbers that multiply to be 16. And just like before, it's going to be 4. But it's going to be plus or minus still. Still going to be plus or minus. All right. Then we got to make our 2 cases. One of them is going to be the plus 4. One of them is going to be the negative 4. So I've got x minus 7 equals plus 4. Then I've got x minus 7 equals negative 4. So I got case 1 and case 2. Case 1, case 2. Alright, all you have to do is solve for x now, right? So I'll do this one with the moving the numbers strategy. So I'm moving this -7 to the other side. It crossed the equation sign. So it's gonna switch signs. So instead of -7, it becomes a +7. Then all I have to do is x equals 4 plus 7. There you go. That is my first solution. Let's look at my second solution. I'm going to do this one using inverse operations. So that's a -7. I'm going to do the opposite of subtracting 7. So I'm going to add 7. Since I'm adding 7 to the left side, I need to add it to the right side of this equation. Right? Always think of this equation as kind of left side, right side. So I've got -7 plus 7 here, so I have to add 7 to this side too. Okay, so -7 plus 7, magic happens, algebra cadabra, and you got +0. And that disappears, which is good. That's what we want, right? Then I've got -4 plus 7. -4 plus 7. Well, in that case, that should be a +3. And that should be it. Let me look at the assignment one last time, make sure I haven't missed anything. Yeah, looks like, yep. So, that is it for this week at the least. And just remember, finish this weekly assignment. We'll have our riddle on Thursday, and then next week we'll be going over exponents, okay? If you guys have any questions, you guys know where to reach me. Google Classroom, my Remind. You can always email me. I know some of you guys have my Google Voice number as well. So you can contact me on any of those. You can also comment on the YouTube videos as well. If you guys need to schedule some FaceTime with me, don't hesitate to ask, okay? I have no life. You know, you can always ask me, just don't ask for something at like 1 a.m. I know some of you guys are night owls, but I can't do that for you guys, sorry. Just try to give me some reasonable hours, all right? Other than that, you guys have a safe day. You guys, please wash your hands. I know some of you guys don't wash your hands. Just wash your hands, please. And have a good day. Eat some good food for me. All right, if you guys have any awesome suggestions on what to cook at home, please send them my way. All right, other than that, I'll see you guys later.